Resources and UTDallas have collaborated to create a solution to this need. My partners in this collaboration are Jonathan Seawright, who specialized in network connectivity and data accessing portions of programming. For example, he implemented and debugged the VPN server. Rajesh Cooney, who specialized in programming the PLC to actually process data, package it, and get it ready for transmission. Christopher Miller, who specialized in system PAL. For example, he selected the battery according to the capacity that we needed, and then integrated all of the components, systems engineering, onto the one battery supply. And myself, I'm Charles Holman. I contributed most in project management and solar energy analysis. So for example, I created this slide, and I'm writing the final project report. At its core, this is a PLC, or programmable logic controller-based system, that takes an input from very simple temperature and barometric sensors as a proof of concept for this device. Is run on 3 solar panels, 45 watt maximum. They're in parallel, so you can easily adjust the number of solar panels that you have. They run through a charging regulator to the battery. We used deep cycle lead acid battery for that. The data router, so once the data is brought into the PLC packages that, and then is sent through the AT&T 3G network to an offsite Amazon EC2 server, which we got for free. Talk about saving costs. To a server that can then be used to download the information to a database. As an example of our problem-solving skills, our data router supplier sent us the wrong unit. So we lost, as a result, about 2 to 3 weeks of time, and found out late that using the dynamic private IP address of the router, it was going to be unfeasible for us to finish actually transmitting the information correctly. So we found a low-cost way to solve the problem by using a Raspberry Pi to initiate the VPN tunnel and then forward the information to the PLC instead of using the data router itself to accomplish that. Also, our system supports multi-rate sampling from the sensors. So each sensor could run at a different rate according to the needs of the application to meet exactly what is appropriate. That's it. Any questions?
Did you build any hardware?
No, this is systems engineering.
Is your system up and running?
Yes. Yeah, we proved the concept. So we have actually transmitted information through the network. Now that we have the correct router and so forth.
Why do you use a PLC instead of like oversight?
Right. The biggest concern is that this has to be industry grade. It has to be used out on an oil rig. It's exposed to elements, temperature extremes. And then the other component is that our sponsor, Integrity Integration Resources, is very familiar with PLCs. They use it for a lot of their other applications, and they strongly recommended it so that their engineers could work with it well.
Any other questions? All right.
Any issues with data arbitration or data flow in this package?
Yes, like I said, with the dynamic private address for the router, we're having difficulty initiating the VPN tunnel, so we use the Raspberry Pi for that. Also, the data, speaking of data security, the data is encrypted over through the VPN. It would also be very easy. We researched another way to add data security level. There's a module that you can add onto this Allen Bradley block that allows interface with C# programming. This runs on ladder logic. They had to learn a new language for this. But you could very easily use that C# to implement a hashing function to add another level of data security.
Your question is on data rate?
Yeah, more like the cable on the network, especially when they don't have always, say, 3G network available, or hackers just don't show up, or how you arbitrate, how you recover it, is a failure recovery in there.
Right. For one, we created a file listing with timestamps for every data sample. That way, even if the network goes down, the information is stored locally in the system. And then we can command the unit from the server, through the server, we can command the unit to retransmit data.
And the data size is very small. I mean, 1 day's worth of data is about 10 kilobytes, 20 kilobytes.
How often do you
Ideally, this would be scalable to whatever the industry wants to measure.
How often do you push the data to this?
You can change it. It's variable according to the needs and desires of the application.
Full